So today we're talking about trigonometry. This is a new unit, and so um, we're going to be a lot. This is going to be review. Okay, we're talking about today specifically how to find side lengths and angle measures of triangles. We're going to start with right triangle trigonometry. This is a review from your geometry days. Hopefully you remember that the side across from the 90-degree angle is called your hypotenuse, and it'll always be your hypotenuse. It is the longest side of your right triangle, and it's always across from 90 degrees. Now the other two are called your legs. Now more specifically, when we talk about like your what your legs are in reference to a particular angle, say angle X here, then this side is no longer called your leg, but it's called your opposite side, and this side is called your adjacent. This is used when you're trying to determine whether or not the measure of an angle or a side length. You use SOHCAHTOA to determine side lengths and angle measures. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. This is in reference to your right triangles and an acute angle. Whenever you're doing SOHCAHTOA, it's always based off of your acute angles, never your 90-degree angle. And sine, cosine, and tangent are always attached to an angle. So you just can't have regular sine. It's actually sine of an angle. So sine of 58 degrees or sine of 2 degrees or whatever. Something else is the tangent of theta equals sine theta over cosine theta, but we're going to talk about that a little bit more once we get into like the coordinate axes in trigonometry of this unit. Okay. In the other video, I go over these two examples on how to use trigonometry to find your side lengths and your angle measures, and so you can use that to you can look at the other video to see exactly how those are worked out. But the main thing is definitely label your sides, so then that way you know what trig function to use. And of course, I will definitely use this time to remind you that whenever you're looking for an angle, you always take the inverse of your trig function. Okay. In this, also in the other video, we talk about special right triangles, how there's a proportion between all your side lengths and how you can use this information to find exact values of angle measures as well as side lengths. And then, of course, you have angles of elevation and depression. Again, I go into a little bit more detail in the other video about this, but the main thing you need to take away is that it always comes from some horizontal line looking up for elevation or looking down for depression. So the rest of this video is going to be actually to apply these concepts, looking at 3 examples, and then you can refer back to trigonometry part 2 to see the rest of this particular lesson. So in this case, we have a equals 2x, b equals 5x minus 1, and c equals x squared plus 1. Of course, x is an integer. That is key. That's what the z means. It means an integer, so that's a whole number, positive or negative. And we're trying to find the value of x in the angles a and b. Hope you can recognize that to find the length of any side, you use Pythagorean Theorem. So that's going to be 2x squared plus 5x minus 1 squared equals x squared plus 1 squared. Okay, you do have to square each side whenever you're using the Pythagorean theorem, and you do have to FOIL. Whenever you're dealing with the binomial. Hopefully, you guys can recognize that, and this is how we would set it up. Now, at this point, we can bring everything to one side, and we can see where this particular polynomial function intersects the x-axis, because technically when we solve for an x value, we're actually looking for the point where the graph crosses the x-axis. So at this point, it definitely can't be factored. I mean, of course you can take out an x, but we're actually going to have to go to our calculator and go to our y equals. We're going to type in the function x to the 4th minus 27x squared plus 10x squared. We type that into our y equals. I'm also going to plug 0 into y2, because what I'm going to use is, when I graph this, I'm actually going to use, there's the graph. I'm actually going to use the intersect feature to see exactly what my values of x are. Now realize that x has to be an integer, so it can't be this value right here because it's crossing in between two whole numbers. It could be this number, but then that means that x would have to equal 0. And if we plug 0 back in here for 2x, that means a would be a length of 0, which is not possible. This again is another decimal. I'm looking for a whole number. So it looks like it might be this value, which is 1, 2, 3, 4, 5. But let's double check that. I'm going to press the second button. I'm going to press the trace button, and I have these options that pop up. I'm going to go down to option 5, click enter, and I'm going to move my cursor that is closer to that x intercept, okay? So I'm going to move it, closer to that x-intercept, and then I'm going to click enter 1, 2, 3 times to see that yes, x is going to equal 5. Okay, this is a feature of using your calculator to help you. X is equal to 5, which means that a is going to be 10. 2 times 5 is 10. B is going to be 24. Oh, excuse me. B is going to be 24. 5 times 5 is 25, minus 1 is 24. And then lastly, C is going to be 26. This here is another Pythagorean triple, 10, 24, and 26. So then to find angles A and B, I really could use any trig function that I want, okay? I'm going to use tangent just for the sake of using tangent. And that's going to be 10 over 24. And I'm going to find the angle. So whenever I find the angle of a, whenever I find an angle, I'm always going to take the inverse. So A equals the tangent inverse of 10 over 24. I'm going to plug that into my calculator, and I'm going to get my answer. All right, so I'm going to plug this into my calculator, and now if you end up getting something like this, then this basically means that I might need to go back and check my mode. And sure enough, I am in degree mode, and so I need to change that. And I'm going to press second enter, which basically pulls the exact same thing I just typed without me having to retype it all in again, and click enter, and it's going to be about 22.6. Okay. All right. Now to find B, let's use a different trig function. Let's use sine. Okay. Sine is going to be 24 over 26, and it doesn't really matter what numbers you use because we know all of them, and every single one is actually going to get us our our answer. So then we are going to do the inverse again because we are looking for an angle. And we always use inverse when we're looking for an angle, and we're going to type in exactly what we see. Sine inverse 24 over 26. Close it off, and 67.4. And honestly, what I could have done, I just realized it as I was doing it, 67.4, is I could have done 180 minus 90 minus 22.6 to actually find angle B. But that's neither here nor there. Still get the same answer. This one you have to find the exact values. Now hopefully you recognize that PQR is a 45, 45, 90 degree triangle because you have two congruent sides and a 90 degree angle. So that means that these two would have to be equally matched. And if you recall from our special right triangles from this slide here, whenever you have 45, 45, 90, you have basically 1x and 1x and x root 2. So whatever the legs are, you can always find the hypotenuse by multiplying it by the square root of 2. So if both of our legs are 8 and 8, that means that x has to equal 8 square root of 2. Okay, so 8 square root of 2 is the value for x. You could also do Pythagorean Theorem. You know, because you do have a right triangle and you do know two sides. The only thing is that you would have to simplify that radical. Now to find z, I would find z next because hopefully you can recognize that this is a 30, 60, 90 degree triangle with 30 being down there where s is. Okay, and with a 30, 60, 90 degree triangle, the side across from your shorter side is x, the side across from your 60 is x square root of 3, and the side across from your 90 degree angle is 2x. Okay, now x square root of 3 basically means whatever your shorter side is, you just multiply by the square root of 3, and whatever your hypotenuse is, you just whatever your shorter side is, you just multiply by 2 to get your hypotenuse. So if x is 8, which it technically is across from that 30 degree angle, to find z, all we do is multiply 2 times 8, which gives us 16. Z equals 16. Lastly, to find y, we're actually going to figure out that this bottom length of the big triangle from Q to S is going to be x square root of 3, or better yet, 8 square root of 3. So to find y, all we do is we take 8 square root of 3 and we subtract it from 8. And that's going to be the value for y. And the reason why that's the case is because QS is basically 8 plus y. And so in order to figure out just y, we have to take that full length, which is 8 square root of 3, and then we have to subtract the value of 8. Lastly, we have this example. An observer stands 100 meters from the base of a building. The elevation to the top of the building is 65 degrees, and we have to figure out how tall the building is. With IB SL to be exact, okay, all of our buildings are going to be vertical buildings, meaning that it's going to create a 90-degree angle with the ground. Always, always. So our observer is basically over here. It's our person. This is our observer. And they're standing 100 meters away from the building, the base of the building, and the angle of elevation is 65 degrees. So elevation always comes from some horizontal line. This is the horizontal line right here, going up to the top of the building. So 65 degrees is right down here, down at the bottom. And we have our 90-degree angle right here. Draw that in. So we're looking for the height of the building to the nearest meter, which will be this. Although you can recognize that we're going to use the tangent function, we always attach the angle to tangent, and tangent is opposite over adjacent, which is x over 100. Now, if the x was at the bottom, like the bottom of the fraction, we would multiply both sides by x and then divide by the tangent of 65. But because the 100 is in the denominator in this case, we're just going to multiply both sides by 100 and see that x is going to be 100 times the tangent of 65. And that's exactly what we plug into our calculator. 100 tangent of 65, close it off, and see that the height of the building to the nearest meter is going to be 214 meters. So the rest of the video kind of goes in, the rest of the lesson is in the other video, part 2. So if you have any questions, please make sure you ask, but go ahead and switch over to that other video.